Einstein's universe, why everything spins. The most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. Albert Einstein. Everything is spinning right now. Earth completes one rotation every 24 hours, creating the rhythm of day and night. But Einstein taught us something profound. This rotation isn't just movement through space. It's movement through space-time itself, a four-dimensional fabric where space and time are inseparably woven together. Earth also travels around the Sun, taking 1 year to complete its orbit. But here's where Einstein revolutionized our understanding. The Earth isn't being pulled by an invisible force. Instead, as Einstein revealed in his general theory of relativity, the Sun's mass curves the fabric of space-time around it, and Earth simply follows the straightest possible path through this curved geometry. What we call an orbit is actually Earth moving in a straight line through curved space-time. The Sun itself moves, orbiting the center of our Milky Way galaxy, taking approximately 200 million years for one complete revolution. And the galaxy rotates as a whole, billions of stars following curved paths through the warped space-time created by the galaxy's massive concentration of matter and energy. Einstein would have marveled at this cosmic choreography. He once said, "I want to know God's thoughts. The rest are details." The spinning universe reveals one of those fundamental thoughts. Rotation emerges from the very geometry of space-time itself. Look at other galaxies through a telescope. They're spinning, almost all of them, giant spirals tracing their paths through the cosmic fabric. Look closer to home. Hurricanes rotate, tornadoes spin. Even the whirlpool in your bathtub follows this universal pattern. So here's the question Einstein would ask. Why does everything spin? Why is rotation woven into the fundamental structure of the universe? Why don't things simply move in straight lines? And here's the deeper question. If planets are orbiting the Sun and moons are orbiting planets, why doesn't gravity cause everything to crash together? Let me show you through Einstein's eyes. The geometry of falling the moon circles Earth right now, orbiting at about 2,000 miles per hour. In Newton's view, two forces were in balance, gravity pulling the moon toward Earth, and the moon's motion keeping it from falling. But Einstein showed us something more beautiful and strange. There are no forces at all. The moon is simply following a geodesic, the straightest possible path through curved space-time. Einstein's geometric insight reveals that massive objects like Earth don't pull on other objects. Instead, they curve the space-time around them, and objects simply follow the natural contours of that curved geometry. Imagine space-time as a vast rubber sheet. Earth's mass creates a depression in this sheet, a curve in the fabric itself. The moon, moving through this curved geometry, traces what it perceives as a straight line. But because space-time itself is curved, that straight line appears to us as a circle. Einstein developed this insight through Gedanken experiments, thought experiments. He imagined being in a falling elevator. Inside that elevator, you'd feel weightless. Drop something, and it would float beside you. Why? Because you and the object are both following the same geodesic through curved space-time. There's no force acting on you. You're simply moving naturally through the geometry of space-time itself. The moon has been following its geodesic for billions of years, tracing a path through Earth's curved space-time. It's not fighting against gravity. It's not being held in orbit by centrifugal force. It's simply taking the straightest possible path through a curved geometry, falling freely through space-time, following the natural contours that Earth's mass has created. This is Einstein's revolutionary insight. Gravity isn't a force. It's geometry. The curvature of orbital motion, Earth orbits the Sun at 67,000 miles per hour, tracing an elliptical path through the solar system. In Einstein's view, we're following a geodesic through the Sun's curved space-time. The Sun's enormous mass, its energy, curves space-time dramatically around it. Earth moves through this curvature, following the straightest path possible. Every planet does this. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all following geodesics through the Sun's warped space-time geometry. The balance between their motion through spacetime and the curvature created by the sun's mass creates stable orbits that persist for billions of years. But where did that motion come from? Why was everything already moving when the solar system formed? Einstein would remind us, God does not play dice with the universe. The motion wasn't random. It emerged from the fundamental laws of physics, deterministic principles woven into the fabric of reality itself. The origin of cosmic rotation. Go back to the beginning. The universe began with the Big Bang, an explosive expansion of space-time itself. Energy converted into matter, following Einstein's most famous equation, E=mc2. Energy and mass are equivalent, two forms of the same fundamental substance. As the universe expanded and cooled, particles formed, eventually becoming atoms, mostly hydrogen. These atoms spread through expanding space-time, forming enormous clouds, gas clouds light years across, floating in the cosmic darkness. But these clouds weren't perfectly still. In Einstein's deterministic universe, nothing ever is. Quantum fluctuations, disturbances from supernovae, temperature variations, gravitational influences from neighboring regions, all created motion. The gas cloud drifted, different regions moving in different directions. Nothing perfectly uniform, nothing perfectly balanced. Some regions moving faster, some slower. Chaotic motion emerging from the initial conditions of the universe. Now gravity, that is, the curvature of space-time, begins working. Regions of slightly higher density curve space-time more strongly. They attract more gas, become denser still, curve space-time even more. A feedback loop develops, exactly as Einstein's field equations predict. The cloud collapses, slowly at first, then accelerating. Space-time curvature pulling everything inward. But here's the crucial point. As the cloud collapses, the different motions of different regions don't cancel out completely. Some net rotation always remains. The cloud as a whole spins, perhaps imperceptibly at first, but measurably. Conservation. In Einstein's universe, Einstein deeply respected conservation laws. He knew that certain quantities remain constant in the universe, unchangeable by any process. Angular momentum is one of these sacred conservation laws. Watch an ice skater spinning with arms extended, rotating slowly. Now watch as they pull their arms inward. They spin faster, dramatically faster. They haven't added energy. They simply moved their mass closer to the axis of rotation. Conservation of angular momentum demands that the rotation accelerate. Einstein would have appreciated this elegant demonstration. It reveals something fundamental about the universe. Rotational motion, once started, cannot be destroyed. It can only be transformed, redistributed, amplified. The collapsing gas cloud follows this same law. As space-time curvature pulls material inward as the cloud shrinks, any rotation it possessed accelerates dramatically. What began as barely noticeable drift becomes rapid spin. The cloud rotates faster and faster, inexorably, deterministically, and as it spins faster, the cloud flattens. Material spreads outward in the plane of rotation, compressed vertically by the geometry of spinning motion. The three-dimensional cloud becomes a two-dimensional disk, a rotating disk. This happens everywhere in the universe. Not sometimes, not occasionally, but always. Collapse plus rotation equals a spinning disk. It's built into Einstein's field equations, into the fundamental geometry of space-time itself. You cannot avoid it. The birth of stars. At the center of this disk, gas accumulates. More material falls inward, following geodesics through increasingly curved space-time. The center becomes compressed, dense, hot. Temperature rises toward millions of degrees. Pressure builds. Eventually, the center becomes so hot that hydrogen nuclei overcome their electromagnetic repulsion and fuse together. Nuclear fusion begins, converting hydrogen into helium, releasing enormous energy according to E=mc2. A tiny fraction of mass converts into energy, and that energy is stupendous. A star ignites. That star inherits the rotation of the collapsing cloud. It must. Conservation of angular momentum allows no other possibility. Our sun formed this way, 4.6 billion years ago from a collapsing gas cloud in our galaxy. It's been spinning ever since, completing one rotation every 25 days. Einstein once observed, "The most incomprehensible thing about the universe is that it is comprehensible." The formation of our solar system follows comprehensible laws, deterministic principles that we can understand and predict. The protoplanetary disk material remained in orbit around the newborn sun, gas and dust following geodesics through the sun's curved spacetime, all moving in the same direction, preserving the original cloud's rotation. This protoplanetary disk is where planets form. Over millions of years, particles collide. When they collide gently, electromagnetic forces cause them to stick together. Dust grains combine with other dust grains, creating larger aggregates. These clumps collide with other clumps, growing progressively larger through countless collisions. Einstein would recognize this as an emergent process, simple rules creating complex structures. Dust becomes pebbles, pebbles become rocks, rocks become boulders, boulders become mountains, mountains become planetesimals. Eventually, planetesimals merge into full-size planets. This process takes millions of years, but it happens inevitably, deterministically, following the laws of physics that Einstein spent his life illuminating. Inherited motion. Here's Einstein's critical insight. Every planet was already moving before it became a planet, already following geodesics through the sun's curved spacetime because it formed inside a rotating disk. The particles that aggregated into each planet were already in motion, already circling the sun. When they combined, they kept that motion. The orbital motion was built in from the beginning. This explains why all 8 planets in our solar system orbit in the same direction. They didn't choose their paths. Physics allowed no choice. They all emerged from the same rotating disk, inheriting the same spin, the same direction. Mercury orbits one way, then Venus, then Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all circling in the same direction, all following the rotation pattern established by the original collapsing cloud. If planets had formed separately from different clouds, they would orbit in random directions, chaotic orientations, different inclinations. But they formed together in one disk from one cloud, so they orbit together, same direction, same plane, following paths determined by the initial conditions of the solar system's formation. The orbital plane is remarkably flat. All planets orbit within a few degrees of the same plane because they formed in a flat disk. That disk was perhaps a few million miles thick, but billions of miles wide. Planets formed within that geometry, so their orbits preserve that flatness. Planetary rotation. The planets themselves spin. Earth rotates once per day. Mars rotates similarly. Jupiter rotates every 10 hours, Saturn every 11 hours. Why do they spin? As each planet formed, as material aggregated from the surrounding disk, that material brought rotational motion with it. Not perfectly balanced, always some net spin. As the planet grew, conservation of angular momentum increased that spin. The planet rotated faster as more mass accumulated. And once spinning through spacetime, the rotation continues indefinitely. In the near vacuum of space, nothing stops it. The motion persists billions of years later, following the inexorable conservation laws that Einstein held sacred. Moons and mini-disks moons formed through similar processes. Large planets created their own miniature disks of material, small-scale versions of the sun's protoplanetary disk. Material orbited these planets, following geodesics through their curved spacetime. That material collided, aggregated, grew, became moons. Jupiter has nearly 80 moons. Saturn has over 80. All orbiting, all moving through curved spacetime, all formed from rotating disks. Our moon likely formed differently. The prevailing theory suggests a Mars-sized object collided with early Earth. The impact was catastrophic, ejecting enormous quantities of material into orbit. That material formed a disk of vaporized rock circling Earth. Over time, it cooled, aggregated, became our moon. Different origin, but same result. A disk, rotation, and an orbit following a geodesic through Earth's curved spacetime. The moon has circled Earth for over 4 billion years, same direction as Earth's rotation, because it formed from Earth's rotating debris. Galactic scales. Consider galaxies. Our Milky Way is a spiral, a massive rotating disk containing hundreds of billions of stars, all following geodesics through the galaxy's collective space-time curvature. The Sun, located roughly halfway from the center, takes about 200 million years to complete one galactic orbit. We're moving at approximately 500,000 miles per hour, circling with all the other stars in our region. Why does the galaxy spin? The same principle that governs everything else. It formed from a collapsing gas cloud, an enormous cloud millions of light years across. That cloud possessed some rotation, imperceptibly slow initially. But as it collapsed under its own gravity, that is, as the curvature of space-time increased, the rotation accelerated dramatically. The cloud spun faster, flattened into a disk, and stars formed within that rotating disk. They've been orbiting the galactic center ever since, for billions of years, following geodesics through the galaxy's space-time geometry. Other galaxies show the same pattern. Most are spirals, rotating disks of stars. Some galaxies are elliptical, less organized, but even those contain rotation. Stars orbit the center in more complex paths, but still rotating, still following geodesics through curved space-time. The persistence of orbits. Why don't planets crash into the Sun? Why doesn't the Moon crash into Earth? If space-time curvature draws them together, why don't they eventually collide? Because they're following geodesics, the straightest possible paths through curved space-time. The Moon is falling toward Earth continuously, but falling through curved geometry. Earth's mass curves space-time, and the Moon follows the natural contour of that curvature. The curve of its geodesic matches the curve of space-time itself, creating a stable orbit. Drop something on Earth and it falls straight down because it has no sideways motion relative to Earth's surface. It simply follows the geodesic directly toward Earth's center. But give something sideways motion while releasing it. It follows a curved path, falling and moving laterally simultaneously. Throw it fast enough and the curve of its geodesic matches the curvature of space-time around Earth. The object falls around Earth instead of into it. That's an orbit. Continuous free fall through curved space-time that never lands. The Moon moves through space-time at exactly the right velocity. Its geodesic curves match Earth's space-time curvature perfectly. It never gets closer, never crashes, simply follows its eternal path through four-dimensional geometry. Earth and the Sun share this relationship. We're following a geodesic through the Sun's curved space-time at 67,000 miles per hour. That velocity determines the shape of our geodesic, creating a stable elliptical orbit. Slow us down, and our geodesic would spiral inward. Speed us up and we'd fly away into deep space. We exist at the perfect balance. This balance characterizes every orbit everywhere. Objects follow geodesics through curved space-time at velocities that create stable, repeating paths. They're not fighting gravity. They're surrendering to it completely, following where space-time geometry leads. Eternal stability. These orbits persist for billions of years, incredibly stable. Earth has orbited the Sun for 4.6 billion years. Same orbit, same distance, same speed. The Moon has circled Earth for over 4 billion years, its path essentially unchanged. Why such stability? Einstein would point to conservation laws and the geometry of space-time. In the near vacuum of space, nothing disturbs orbital motion. No air resistance, no friction, no energy loss. Objects follow their geodesics indefinitely. Energy is conserved, momentum is conserved. The geometry of space-time doesn't change significantly. The orbits persist. On Earth, everything eventually stops moving. Friction converts kinetic energy into heat. Motion ceases. But in space, these processes don't occur. Objects continue moving, continue orbiting, essentially forever, unless something catastrophic intervenes. This is the natural state of Einstein's universe. Once something begins moving through space-time, it continues moving. Once something begins following a geodesic, it continues following that path indefinitely. The motion never stops. Earthbound rotation. Even on Earth, we observe the spinning pattern. Hurricanes rotate because Earth rotates. Earth's rotation means different latitudes move at different speeds through space. The equator moves at about 1,000 miles per hour. Regions near the poles move more slowly. When air flows between latitudes, it's moving over ground, rotating at different speeds. The air gets deflected, begins rotating. This is the Coriolis effect, a consequence of Earth's rotation through spacetime. Warm ocean water evaporates, rises, creates low pressure. Air rushes inward. That air is rotating due to the Coriolis effect. The rotation organizes into a spiral. Energy from warm water amplifies the spin. The result? A hurricane, a giant rotating storm with winds exceeding 100 miles per hour. Tornadoes form through similar principles. Thunderstorms create powerful updrafts. If wind shear exists, the rising air begins rotating. As the column stretches vertically, conservation of angular momentum accelerates the rotation dramatically. The result? A tornado, a violently spinning vortex with winds exceeding 200 miles per hour. Even water spiraling down a drain demonstrates the pattern. Any disturbance creates rotation, and that rotation persists and amplifies. Universal principles. Einstein spent his life seeking unified principles, fundamental laws that explain diverse phenomena. The rotation of the universe reveals such a principle. Motion through spacetime, once initiated, persists indefinitely. Gravity, the curvature of spacetime, amplifies and organizes that motion. Tiny random drifts become organized rotation. Chaos becomes structure. The pattern repeats at every scale, from the smallest whirlpool to the largest galaxy. Small gas clouds collapse and become spinning stars. Enormous clouds collapse and become spinning galaxies. Disks around stars become orbiting planets. Same physics, same geometry, same inevitable results. The eternal mystery of the world is its comprehensibility, Einstein wrote. The spinning universe is comprehensible because it follows deterministic laws, geometric principles embedded in the structure of spacetime itself. Look upward at the night sky. Every star you see is spinning. Every planet around those stars follows geodesics through curved spacetime. Every galaxy rotates, all connected by Einstein's revolutionary insight, mass and energy curve spacetime. And objects follow the straightest possible paths through that curved geometry. You're standing on a spinning planet, following a geodesic through the sun's curved spacetime. That sun orbits through our galaxy's collective spacetime curvature. That galaxy emerged from a rotating cloud, and that rotation traces back to the initial conditions of the universe itself. The spin goes all the way back to the beginning, persisting through billions of years because conservation laws are absolute, and space-time geometry is deterministic. That's why everything spins. Not because something actively makes it spin, but because rotation, once begun, cannot stop. Physics preserves it, amplifies it, organizes it into the elegant cosmic structures we observe. As Einstein understood, the universe reveals a profound beauty in its comprehensibility. From quantum fluctuations to galactic superclusters, the same principles apply. Space-time curvature, conservation laws, geodesic motion. These principles weave rotation into the fundamental fabric of reality. The spinning universe is Einstein's universe, deterministic, geometric, comprehensible, and ultimately, profoundly beautiful.